哪？我晓得。哇，就是算了，还是听那个。
引入了二维随机变量，介绍了二维随机变量的分布，特别讨论了两种常见的这个二维随机变量，一种是不散的，我们研究它的分布率；还有一种呢是连续的，我们研究了它的这个分布的密度函数。那么这一讲我们将介绍一个新的概念，就是一个边缘分布。这个边缘分布呢是什么意思呢？就是我们知道 x y 这个作为一个二维的随机变量或者是随机向量，它有一个整体的联合分布函数，比如说是这个大 f x y。那么我们就要问，这些小的 x y 如果作为单个的随机变量，它当然也是有一个分布的。那么它的这个分布跟原来的联合分布有什么关系呢？实际上上一堂课我们有一道例讨论这个问题，就是已知给了你一个，当时是给了我们的一个 f x， 假设是 f x y 已经算出来了，是吧 ？f x 算出来了，我们要求这个东西，要求这样一个东西的概念，是吧？要注意啊，在二维的随机变量中间，这个是什么？这个记号的意思，是吧？这个记号的意思，实际上你应该理解成什么呢？应该理解为所有的这样一些 x y， 是吧？所有的这个 x y， 就是这个 x 呢要小于等于 x，y 呢实际上是无限制，因为 y 呢可以取一切的值，可以取一切的值。那么取一切的值就等价于什么？就等价于这个东西啊，就我就可以写成是把这个 y 小于 y， 然后再让这个我要表明它是一切值无限没有限制，就让这个什么这个 y 取正无穷，啊，让这个 y 取正无穷，这样的话这个 y 就相当于对这个大 y 来讲是无限制，那就是这样一个事情。也就是说这个东西它是一个变成一个必然事件，对吧？是个必然事件。特别在这个情况下，我们就得到了单个的随机变量 x 的一个分布函数，因为这个我们知道，我们原来学一维随机变量
这样效率太低了呀，
就是单个的 x。
这样说的好，但效率太低了。假如我只选了听课的话，效率太低了。最好是直接去搜。比较靠谱。然后多看，多思考。然后不行，再到不行。所以我要什么呢？就这个。我也觉得。就比如像这个，你有了这个之后再去搜索，那可能就会有。
In this video, we're going to work on some hypothesis testing problems with 2 sample means.
算了，有了谁让一个改了？这个都挺简单。
Welcome to a lesson on how to display categorical or qualitative data given in a frequency table as a bar graph, Pareto chart, pie graph, and a pictogram. Categorical or qualitative data are pieces of information that allow us to classify the objects under investigation into various categories. We usually begin working with categorical data by summarizing the data in a frequency table. Where a frequency table is a table with 2 columns, as we see here. One column lists the categories, and the other for the frequencies with which the items in the categories occur, meaning how many items fit into each category. Looking at the frequency table, we can tell that 10 students received an A, 12 students received a B, 15 students received a C, and so on. If we sum the frequencies, we can determine the population. You can see here would be 40, so there were 40 students in the class. Let's begin by displaying this information as a bar graph. To construct a bar graph, we need to draw a vertical axis and a horizontal axis. The vertical axis, so there were 40 students in the class. Let's begin by displaying this information as a bar graph. To construct a bar graph, we need to draw a vertical axis and a horizontal axis. Sum the frequency. And a horizontal axis. The vertical axis will have a scale and measure the frequency of each category. Here's our vertical axis. Notice how the largest frequency is 15, and therefore the vertical axis is scaled to 16 by 2's. The horizontal axis shows the categories. Again, here we see the letter grades, and the bar height shows the frequency. So for A, the frequency is 10. Notice how the bar has a height of 10. For B, the frequency is 12. So for B, the bar has a height of 12, and so on. Sometimes you also see the frequency listed at the top of each bar like this. Now let's talk about a Pareto chart. Sometimes our chart might benefit from being reordered from largest to, for B, the frequency is 12. So for B, the bar has a height of 12, and so on. Sometimes you also see the frequency listed at the top of each bar like this. Now let's talk about a Pareto chart, largest to smallest frequency. This arrangement can make it easier to compare similar values in the chart, even without grid lines. When we rearrange the categories in decreasing frequency order like this, it is called a Pareto chart. So here's the original frequency table. If you want to reorder this from largest frequency to smallest frequency, we have to switch the A's and the C's so that the highest frequency of 15 is first, followed by 12, 10, 2, and 1. Now if we use this frequency table to make a bar graph, it will be a Pareto chart. So the orange graph is a bar graph. This purple graph is a Pareto 10, 2, and 1. Is a Pareto chart. Again, looking at the frequencies, notice how they go from largest to smallest. So now the categories are in the order of C, B, A, B, F. And again, sometimes you will see the frequency listed at the top of each bar. Now let's display the same data as a pie chart. To show relative sizes, it is common to use a pie chart listed at the top of each bar. Now let's display the same data as a pie chart. Is marked out like
skip navigation.
The relative sizes of the wedges correspond to the relative frequencies of the categories. So here's the pie chart. This wedge represents the A's. This wedge represents the B's, C's, D's, and F's. Notice how this is created using software, which is very common these days. If we have to do this by hand, one circle represents 360 degrees, so one way to determine the size of each wedge would be to use a protractor, which measures angles. And because the total number of students is 40, the sum of the frequencies, 10 of them have A's, the letter grade of A represents 25% of the total population, or in this case, 25% of the circle. And so if we find 25% of 360 degrees, which is 90 degrees, we can measure out 90 degrees to create this wedge. And we can do the same with the other letter grades, but again, normally we just use software to create pie charts. The last graph we'll take a look at is called a pictogram. A pictogram is a statistical graph in which the size of the picture is intended to represent the frequencies or size of the values being represented. And there are some variations of pictograms. Notice here, Instead of bars, we're using pictures of A's, B's, C's, D's, and F's. So it is very similar to a bar graph. Often you will see the frequency listed at the top of each picture. Notice how here the image of each letter is the same size. Another option is to stretch each image to the correct height, as we see here. A labor union might produce the graph to the right or below here to show the difference between the average manager salary and the average worker salary. Looking at the pictures, it would be reasonable to guess that the manager salaries are 4 times as large as the worker salaries, because it does appear the area of this larger bag is 4 times as large as the area of this smaller bag. However, the manager salaries are in fact only twice as large as the worker salaries, which are reflected in the picture by making the manager bag twice as tall. So here this pictogram can be deceptive unless you pay close attention to the height of each of these rather than their size. Looking at the scaling on the axes, notice how this larger bag is twice as tall as this smaller bag, representing the salaries are only twice as large, not 4 times as large. Okay, that's going to do it for this lesson. I hope you found this helpful.
Okay.
Welcome to the lesson on the shape of a distribution of a variable. The distribution of a variable shows all possible values the variable can take on and the frequency that each of the possible values occurs. The distribution can be shown as a list, table, or a graph. Here we see several distributions shown as bar graphs. In statistics, when setting distributions, we have to look at the following characteristics: shape, outliers, center, spread. These are sometimes referred to as the socks of the distribution. Common distributions through their shape are bell-shaped or normal, symmetric, right-skewed, left-skewed, unimodal, and bimodal. However,
So let's say you were to go to a restaurant, and just out of curiosity, you want to see what the makeup of the ages at the restaurant are. So you go around the restaurant and you write down everyone's age. So these are the ages of everyone in the restaurant at that moment. And so you're interested in somehow presenting this, somehow visualizing the distribution of the ages. Because you wanted to say, well, are there more young people? Are there more teenagers? Are there more middle-aged people? Are there more seniors here? And so when you just look at these numbers, it really doesn't give you a good sense of it. It's just a bunch of numbers. So how could you do that? Well, one way to think about it is to put these ages into different buckets and then think about how many people are there in each of those buckets. Or sometimes someone might say, how many in each of those bins? Well, let's do that. So let's do buckets or categories. So I like to call a bin. So the bucket, I like to think of more as a bucket. The bucket, and then the number in the bucket. The number. What's that number? Whoops. It's the number. It's the number in the bucket. All right. So let's just make buckets. Let's make them 10-year ranges. So let's say the first one is ages 0 to 9. So how many people? I know I'm just define all of the buckets here. So the next one is ages 10 to 19, then 20 to 29, then 30 to 39, and 40 to 49, 50 to 59. I'm sure you can read that properly. Then you have 60 to 69. I think that covers everyone. I don't see anyone 70 years old or older here. So then how many people fall into the 0 to 9-year-old bucket? That's going to be 1, 2, 3, 4, 5, 6 people fall into that bucket. How many people fall into the 10 to 19-year-old bucket? Well, let's see. 1, 2, 3. 3 people. And I think you see where this is going. What about 20 to 29? It's 1, 2, 3, 4, 5 people. 5 people fall into that bucket. All right. What about 30 to 39? We have 1 people. So then people. Right, smaller. 30 to 39. That's going to be this bar right over here. We have 1 person. 1 person.
这他妈太蠢了，我操！整这还不如直接整那个，我操，那没有时间，我他妈的。 对呀，浪费时间啊，只要这样好了。嘿嘿，我真是天才，这不就搞定了吗？浪费什么时间？这数只能25个是吗？这简单的算了吧。这里怎么说？看怎么说。可以。那怎么说？太强了！我操，太强了！真他妈太强了！以后那玩意可以实验了，我操！这太强了，12分，12分，之前就用这个，看书。太强了！我操，太强了吧！强！那是真他妈地狱！我操！所以这个下列子在。Official interview question， 这可以啊。那钱没关系。哎呀，能花钱都是小意思。现在先把简单的东西先给我搞清楚，再来考虑。牛掰！ 有。妈的，这都没搞毛了，这都没弄完，说什么？可以，倒是没啥毛病就是。Random problems. 都是搞笑的。这么想啊我，整这个我操，过分了，过分了。我操！我要我要把这个给弄上去了，行吗？行的。哎呀！看他这什么反应我操！这杀也太强了！太屌！太强了，我操！他妈头都给打晕了，我操！星期天嘛。这什么时候？这我可以参加吗？一颗空天，讲这好东西。 操，有这么多好东西啊！说这些疫情的朋友是。我就算了，多学学吧。OK，就这样，没啥问题，搞定。